Hello, this is the core summary of ChoWorld. This time, because it pertains to the content of an AI-related paper, I will first provide a specialized explanation and then give a simple summary that can be easily understood. DeepSeek used a reinforcement learning technique in the R10 stage to develop a powerful natural language processing model. R1. This technique applies both an accuracy reward and a format reward simultaneously, allowing the model to gradually form a more complex thought process. In short, DeepSeek is a technology designed to help an AI develop its own thinking, and R10 can be considered an intermediate stage to test that technology. The research team at Berkeley applied this R10 reinforcement learning structure directly to a small model, creating Tiny Zero by solving problems where a specific value is produced by combining given numbers. They confirmed that the model's chain of thought develops. More clearly stated, Tiny Zero is a small AI model built using the DeepSeek approach, demonstrating that it can expand its reasoning by solving tasks like math problems on its own. The chain of thought refers to the AI's logical narrative of the processes it goes through before arriving at an answer. Research has shown that extending this process through reinforcement learning improves problem-solving capabilities. In other words, if the AI increasingly extends the step-by-step process of thinking about why this answer is correct before giving its final answer, its ability to find the correct solution improves. The notable point in the Tiny Zero experiment is that the GPU usage cost is estimated to be about $30. This refers to the pure computational cost, excluding labor or other expenses. It has been reported that when training DeepSeek's final model R1, the team used GPUs for millions of hours, costing more than $5 million. The accuracy reward is a method that gives a high score when the answer is correct, while the format reward is set to provide additional points when the predetermined output format is followed. If, through this dual reward system, the model produces an appropriate flow of thought, it ultimately enables step-by-step reasoning, similar to how humans solve problems. In other words, by dividing the reward into two types, the AI also gradually lays out its thinking process like a human. Tiny Zero has proven capable of generating a good chain of thought for certain tasks, such as math equations. But a larger model is still required for more general conversations or complex reasoning. In simpler terms, this small model solves simple problems well, but it is not yet advanced enough to be applied across all domains. According to the DeepSeek team, when adding up only the GPU time spent on training the V3 model, the cost amounts to about $55776 million. This figure excludes the experimental research and engineering expenses before R10, reflecting only the pure computation cost used for training the V3 frontier model. Tiny Zero was implemented as a proof-of-concept POSE model focusing on limited tasks such as math problems. In comparison, large-scale models that aim for generality and high accuracy require far more training costs to support a wide range of tasks. In simple terms, while a small model like Tiny Zero can solve specific tasks cheaply, creating a complex and versatile model requires a very large investment. However, it also proves that even with relatively small costs, it's possible to confirm the basic functionality of an initial model. Furthermore, if better hardware is added, following the laws of scaling, we can expect even better performance. The data generated through this reinforcement learning method ultimately serves as the initial, or cold start, material for training large-scale models like V3. In other words, it provides the groundwork for teaching the larger model the thought process created by the smaller model. In the end, Tiny Zero is an example demonstrating that AI can strengthen its own logical reasoning through reinforcement learning, and that costs can be significantly reduced depending on the circumstances. This experiment effectively showed how AI can develop its own thought processes, and because the model is small, it costs less, making it all the more meaningful.